Hello friends, myself Rajendra Mahajan presenting my video on inverse Laplace transform. Let us find inverse Laplace of s minus 2 whole divided by s square into s square plus 4. If you observe the terms in the denominator, there are two factors. The first one is s square, repeated factor, and the second one is s square plus 4 as a quadratic factor. And therefore, to find the inverse by partial fraction method, why partial fraction method? Because the degree of numerator term is 1 and degree of denominator term is 4. 1 less than 4 means it is a proper fraction. Therefore, applying partial fraction technique, we can rewrite that term s minus 2 divided by s square into s square plus 4 as a upon s. It is repeated second time, therefore b upon s square. This is way to write partial fraction if factor is a repeated factor. And for that quadratic, a way to write is cs plus d divided by s square plus 4. We call this as equation 1. Then finding LCM. LCM is here s square into s square plus 4. Then dividing by this s to this s square into s square plus 4, we get s minus 2 is equal to 1s get cancelled. Remaining term is s into s square plus 4. Therefore, a multiplied by that term s into s square plus 4. Then dividing by s square to this term, s square get cancelled. Remaining term is s square plus 4. Therefore, b into that s square plus 4. Then dividing by this s square plus 4 to this product of s square into s square plus 4, s square plus 4 get cancelled. A remaining term is s square, and therefore that cs plus d multiplied by that s square. Then multiplying term by term inside the bracket, we get as cube first term, then 4as, then bs square, then 4b, cs cube, and ds square. Then collecting the terms of s cube in one bracket, therefore there are two terms of s cube. Remaining terms are a plus c into s cube. Then there are two terms of s square, this bs square and ds square. Therefore, taking s square common from it, we get remaining term as b plus d into s square. A single term of s, therefore 4as, and only one term of constant term, that is 4b, and that is equal to s minus 2. Then comparing these two sides, comparing the coefficient of s cube, the coefficient of s cube on right hand side is a plus c, and no term of s cube, therefore it is 0. It implies a is equal to minus c. Then coefficient of s square is b plus d. B plus d, and there is no term of s square on the left side, therefore its value we equate it to 0. B is equal to minus d. Coefficient of s is 4a, and coefficient of s on left side is 1. Therefore, we get A is equal to 1 by 4. Constant term 4b on right and constant term on left is minus 2. Therefore, we get b is equals to minus 2 by 4 means minus 1 by 2. Substituting all these values, get the value of c as minus a minus 1 by 4 and value of d as minus b minus of minus 1 by 2, we get that value as 1 by 2. And substituting all these values in equation 1, we get s minus 2 divided by s square into s square plus 4 as a. The value of a is 1 by 4 divided by s, then b minus 1 by 2 divided by s square, c minus 1 by 4 s plus d is 1 by 2 and whole divided by s square plus 4. Taking inverse on both sides, and therefore inverse Laplace of s minus 2 whole divided by s square into s square plus 4 is equals to 1 by 4 constant term outside, inverse Laplace of first term 1 by s minus 1 by 2 inverse Laplace of 1 by s square, then minus 1 by 4 inverse Laplace of s divided by s square plus 4 and plus 1 by 2 inverse Laplace of a separate division by s square plus 4, we get 1 upon s square plus 4. And therefore, inverse of left hand side is some f of t. 1 by 4, inverse of 1 by s is 1 minus 1 by 2. Inverse of 1 by s square is t minus 1 by 4. Inverse of s upon s square plus 4. Standard result, it is cos of 80. A is here 2. Therefore, cos of 2t plus 1 by 2. 1 by a is 2, therefore 1 by 2. Sin of 80, sin of 2t. Final answer as 1 by 4 minus t by 2 minus cos 2t divided by 4 and plus sin 2t divided by 4 as the required answer. Example number 2. Find inverse Laplace of 3 divided by s square plus s using integration method. What is that integration method? For that, let if Laplace of f of t is f bar of s, then Laplace transform of integration from 0 to t f of t dt is 1 by s into f bar of s. Transferring this operator L to right hand side, it becomes inverse Laplace of 1 by s into f bar of s as integration from 0 to t of f of t with respect to t. Therefore, we have to apply this theorem to find the inverse of 3 upon s square plus s. How? That I will explain in next part. That 3 divided by s square plus s we can rewrite as 3 divided by, taking s common from the denominator term, we get s plus 1. And therefore, taking inverse on both sides, inverse Laplace of 3 divided by s square plus s, nothing but 3 is constant term we take outside, inverse Laplace of 1 by s into 1 upon s plus 1, and therefore it is 3, applying the previous property or above property, whatever just I have explained, it is nothing but integration from 0 to t f of t. F of t means the inverse Laplace of that 1 upon s plus 1 and its integration with respect to t. It is 3 into integration from 0 to t, inverse of 1 upon s plus 1, as per standard result, it is e raised to minus t, and then integrating it with respect to t. Three multiplied by, integrating this e raised to minus t with respect to t, we have the integration as e raised to minus t divided by minus 1, limit from 0 to t, it is 3, cancelling that minus sign by changing the limit, 0 become upper, t become lower, e raised to 0 we get 1 minus, for lower limit it is e raised to minus t, as inverse by that integration method. Therefore, f of t is equal to 3 times 1 minus e raised to minus t. Therefore, in this video I have discussed two simple examples how to find inverse Laplace transform. In my next video, I will discuss some problems from Laplace transform. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.